we are the students from KJ Somaiya Science, and we are doing a project in association with IIT Bombay. Our project name is Autonomous Road Mapping Robot, and myself, Ankit Trivedi, and these are my group members, Ankita Shudriya, Rahul Patil, Pratmesh Kapurkar. Now, first let us give a short introduction about the road mapping robot. Basically, what our robot is going to do, the robot is going to move in a particular arena, and is going to do the wall crawling, and he will map each and everything, every obstacle, every walls, and he will navigate in a particular arena. Now let us see one of the demonstration of this robot. This is our arena. Now these are the obstacles which we have placed in the obstacle. Now before that, let us give a short description about the arena. Now the arena has the dimensions of the arena is 140 centimeter by 140 centimeter, and the small blocks which you can see here is about 20 centimeters. So what it actually is doing, and every time when the robo is going to move, it will take only one step. Either he will move forward, he will take a right turn, or he will take a left turn, and he will move in a wall only in one direction, that is clockwise direction, and he is always going to move the boundary of a particular arena. He will never go inside the arena and scan the particular room. Now what we are actually doing, we are using two type of mapping techniques. One is the 180-degree scanning technique, and other is matrix generation. In matrix generation, we are going to generate a matrix by which when there is free space, then it will be denoted by 0, 0, and when there are obstacles, it will be denoted by 1. So, and one is the 180-degree scanning. In the servo motor which you can see, and on that IR sharp sensor is we have mounted the IR sharp sensor, and the range of that sensor is 10 to 80 centimeter. So what the robot, the servo will move from 0 to 180 degree, and he will take approximately 21 samples, and these samples will be transmitted to the PC via Zigbee module, which you can see here, and the transmission can be displayed on the this software, that is XCTU software. So now let us see the whole demonstration and how the output is coming. Let us see the output. Now this robot will move from, this sensor will move from 0 to 180 degree, and he will take 21 samples. And on the screen you can see on the screen you can also see the coordinates, in which coordinates the block is, and also you can see the theta and r value. And accordingly, first the robot will take 21 samples. And after that, he will check for the matrix generation, he will check where the obstacles are there, and then he will take the action of navigation. Now the robot will move forward. Now let us see the output on the software, how we are getting the output. The wireless transmission we are getting, and somewhat like this output. These are all the values. In with the first, we have at every sample we get 4 values. The first 2 samples are x and y coordinate. The third value is of theta value, and the last value is r value. So like this, this is the way in which the robot will scan the entire arena, and when it's returned back to 0, 0 condition, it will send the matrix and the operation will be stopped. This way the overall arena will be mapped. Now these are the certain situation where the robo has to take the decision of navigation. Now this is one of the condition when the obstacle is at front and the robo has to navigate without coming. Now there is an obstacle in front of the robo, so the robo should avoid the obstacle and take a appropriate path so that it should not collide with the obstacle. So if we take the accordingly, then accordingly you have to take the navigation decision. This is the Zigbee model which we are using for the serial communications for the communication for the robo and the host PC. Now what we did for the mapping, for displaying the mapping, we are using MATLAB software. So in the MATLAB software we had wrote the over program, and when we will now the Zigbee transmission is going on, and when we will press F5, the whatever data is stored in the program will be displayed. So this is the particular our output which will be displayed. So all the 21 samples which I get from each and every block will become displayed here, and these are the obstacles which we have detected, the robo has detected, and in such conditions we will get the position, location and the dimensions of the walls and also of the obstacles. So this is the overall project of us which is boom mapping.